Good afternoon, everyone. It's Thomas McGonigal. I'm here with my new friend, Henrique. And Henrique is in the south of France, and I'm in Massachusetts. So two ends of the world. And so I just wanted to say thank you, first of all, Henrique, for coming today. And I think it's after close of business for you, right? Like, what time is
It's
it in
it's
France?
it's actually the 8th of May, which is a national bank holiday, and it's 6 p.m. It's the official beer hour,
It's
beer time
official beer hour. Yeah. Oh my goodness.
so
And it's a holiday. You
and
are a
it,
champion for being on my webinar. I'm gonna when we finally meet in person, I'm gonna buy you some of that beer we were just talking about. And so thank you very much for being on.
you're welcome.
Really, what we're trying to talk about today is cloud observability, network observability. I'm gonna share my screen real quick, Henrique. Henrique, I'm wondering if you have seen this zero trust pillars, right? So one of the things that's really fascinating me these days is is zero trust. Are you familiar with zero trust? Have you heard about this
Maybe you
concept?
can remind me the concept of real zero trust, but I
Yeah.
think
Yeah,
I
so,
guess I'm pretty aligned. But let me make sure that I'm aligned with you.
yeah, of course. I'm actually hunting for a tab in my StreamYard. This is odd the way it got organized. Um, I don't want to share the whole screen. Let's see. Um, just give me. Oh, I found it. Is that it? Yeah. If you've ever seen this before, so verify explicitly, never trust, always verify, and assume breach. Has any of these like jumped out at you? Have you ever heard of zero
Yeah,
trust like, in this context? Yeah.
yeah,
Uh,
sure. I mean, especially if you're moving your workload more and more to the cloud, then yes, this zero trust security approach is
yeah.
definitely something that needs to be implemented for sure.
Well, part of the reason why I'm so kind of jazzed about it is, it's literally the biggest market I've ever encountered, man. Like, you're talking about every device, every application, every IoT device. And here in my office, I have a scale. Like, I have a smart watch. I'm not wearing it the second I'm charging it. I have my phones. I have my TV. I have an Apple TV in my office, and all these devices, are eventually going to be have this kind of individual connection up to like a provider like Cloudflare. And Cloudflare is basically my favorite zero trust provider. But and so if you can imagine, there's like this like it essentially looks like a VPN for every single device, every single app, on your mobile phone, connecting you up to the network. And so I know you're an expert at Cilium and eBPF, and I think it's just this huge opportunity for observability using eBPF. And so would you mind defining what eBPF? I'm gonna stop sharing so I can look at you again. But would you mind defining what the extended Berkeley packet filter is? It's
Yeah,
pretty hard. Please.
yeah, sure. So BPF, so that was the main version that was being implemented in the 90s. In fact, to be honest, when they started to say, "Oh, we need to filter packets, we need to be able to drop packets based on rules." So instead of having a program that's continuously basically pull the packets from the network card, which is not efficient, this BPF technology was been designed from a kernel perspective. So in Linux, a certain version of Linux, you have the options to build a program. When you compile it, then this program will run in the kernel space. So there's a user space in Linux, and there's the kernel piece. And here, basically, the program is running in the kernel. And you basically, when you have a BPF program, you register it to syscall events or kernel events, and then the program is triggered. So in 90s, initially there was mainly networking kernel events that was supported by BPF. And so basically, when you were receiving a package, our program was triggered. The program was able to see what was inside of the packet, and based on the rules, either you have the option to say, "Oh, I'm going to drop it," so then it doesn't basically go in the systems itself. So that was the main origin, and then this technology has been extended over the years and now called eBPF. So at the end, it's a similar technology. It's just that now we have all the kernel systems that we can reach out to, which is quite exciting. And then the other thing is that the storage, now we can store more information to share information. Because if you have just a program sitting in the kernel space doing stuff, but then you have no way of getting information, doesn't make sense. So that's why usually you have a eBPF program sitting in the kernel, and then in the user space you have another piece of program, and the eBPF program will run data information in a storage, and that storage called BPF maps. So at the end you can store lots of different type of information, and then the user space, the program that you have built, will be able to read in that BPF map, which means this is perfect for security use cases and observability. I mean, it's crazy. Instead of having a program just pulling information every seconds from the CPU, you can have a program basically will be triggered every time there is a CPU instructions, and they will collect the information, the process, the time, the waiting, and then push it back, store it in the BPF map. So I think this technology is great because it's just changed the game on how we build solutions for security use cases, and of course, like I said, in observability.
So Henry, I had the opportunity to go to a very good cloud native kind of Kubernetes meetup in Boston, and there was a person from the Cilium team, and the startup that was built around them. I can't recall what the name of them are. I'll have to look it up. But the best example he gave, I found, of eBPF was as a replacement for IP tables. And so what you could do is, like with IP tables, like the rules are sequential. So if you have to change something in the middle, you have to unload them and reload them essentially, like the way like PICs used to work with Cisco PICs, for example. And then with IPFW, and you mentioned it, like sorry, no, not IPFW, with eBPF, and you mentioned it, is you have this hash map, and so you can just change, an individual like key value pair, and then just instrument that, just load that into your firewall. And so that kind of blew my mind. That's a great use case. And then go ahead.
Liz Rice and the other, boards from Cilium, a few years back, I really like the way they compared eBPF. They're comparing eBPF with the evolution of browsers. So a few years back, we just had this statics page where we had a server sending these HTML, whatever page structured. And then on top of that, suddenly we added some code executing on the client side, and that will basically adjust the structure of the DOM on the fly based on events that happens on the browser. And that's basically the same thing, but on the kernel side. So basically we have a JavaScript language that will run on the kernel.
That's a great analogy. I do remember that from the meetup that I went to, and that was my impression. We have this little programmability now built into the kernel that we didn't have before. And stop me if I'm right, if I'm wrong, but we have the ability to instrument and take action on any like kernel syscall, right? Isn't that right? Like,
yeah,
that's
completely
powerful. Yeah. I don't know how many syscalls there are anymore.
There is so many, it's just crazy. In fact, that's the problem, is to figure out which kernel systems make sense for my program. But you mentioned something what was very interesting. You mentioned IP tables, and I don't know if you've been running large Kubernetes clusters, but Kubernetes, I love Kubernetes technology. To be honest, I'm working on that on a daily basis. But Kubernetes, the way the DNS and the routing happens on the cluster is based on IP table rules. So every individual services that we create in our cluster, there is an IP table rule per node. So at the end, if you have, if you have a huge cluster, let's say with 1,000 services running, then you have 1,000 rules per node. So if you have a cluster with 6 or 7 nodes, then your Kubernetes cluster is continuously scanning those rules based on what has been defined, and that could be at the end a bottleneck. So I think the best way of utilizing, for example, the solution like Cilium is basically taking advantage of eBPF to remove these IP tables and do the network routing through eBPF. And I think that resolves also lots of performance limitation that you can face when you run your workload in Kubernetes.
Do you think it'll reduce the complexity?
I think it doesn't it add extra value specifically on the zero trust side, where you can create because in Kubernetes you have the network policies that you can create, which is very limited. You can basically base on IP sources and stuff like this. And here they have this Cilium network policies where you can be at the application level. You can even put rules based on, oh, if I have these HTTP methods on this service with this parameter, just drop it. So you can be very precise on the rules, going very low level on the network to the higher level of the application. And I think this is very exciting because when I first saw the network policies in Kubernetes, I thought that is fantastic, but how can I use it efficiently? And I think with Cilium in their technology, it's much more easier.
I think kube proxy is just a big front end for IP tables too, right? Like, I'm
Yeah,
pretty sure.
kube proxy.
Yeah.
From the moment you put Cilium in your cluster, basically you get rid of kubedns, kube proxy, and then basically it's going to be Cilium who takes it over. That's why AWS, Google, GCP, Azure, they have a specific flavor of the cluster when you deploy it. So then when you ask for that flavor, then you get Cilium right away. Because if you want to deploy the Cilium in your managed cluster, it's barely impossible because you have to change the master nodes, and which you don't control.
No, so I noticed it in DigitalOcean. I have like a one node kube. I'll tell you about it in a minute. But next week I'm teaching a course or a tutorial at a conference in Dallas, and I'll tell you about that in a minute. But as part of that work, I spun up like an inexpensive DigitalOcean one node Kubernetes cluster, and I noticed right away Cilium, was running in. I think it's its own namespace, but whatever, it doesn't matter. But like, I was curious, and I did not know that EKS and AKS and GKE had Cilium installed as well. But it makes sense, right? It's that efficiency that you mentioned. That really makes a lot of sense. Thank you for sharing that.
And I think DigitalOcean was the first one of investing and taking the bets on let's take advantage of Cilium in our clusters.
Can you define Cilium? What exactly is that?
So Cilium so there are lots of various use cases of using Cilium. So you can use Cilium just for security and putting some network rules to say, oh, this service is only reachable from this namespace with this service or with this label, so you can secure the communication between services. Because in the end, if you look at let's say a vanilla Kubernetes cluster, you don't have those options except if you put network policies. So you can basically create fine-grained rules on who can reach out to who. So then you control at least how I exposing my services within my cluster. So that was one of the first use cases. The second use case that they introduced was the service mesh story. So now they have this solution. So the first version they had released was Istio combined with Cilium. So that was still using sidecar proxies to do the proxy with the mesh. Mm-hmm. And now they have introduced 1 year ago the service mesh without any sidecar. So basically all the communication, the rules that is defined in the service mesh from a control plane to the data plane goes through the eBPF technology. So then you remove some steps to resolve, for example, who should I reach out to make the communication. So I think that was one efficient way. And the last piece that they have introduced again a couple of years back was Humble. So I think Humble it's come very fine with Cilium, because with eBPF you know who is talking to who, what is the response times, what is the latency, lots of the various observability metrics that you can get very easily, and Humble is the solution to do that. So it's going to be basically collecting information that Cilium expose, store it, and then you have this service map visualizations. You can even see whose communication has been rejected, dropped, accepted. So then you have like a dashboard showing if the various security policy that you may have applied in your cluster. So I think that's quite efficient as well.
Wow. And so what I'd really like to do is kind of directionalize our conversation around, observability. And so, where does Cilium and and eBPF fit in the observability space? Is it that awareness of the system calls? Do you think that's really kind of the crux of it, or is
I
it
think
something more?
yeah. There, I mean, when you deploy, if you don't have any observability solutions, or if you start your adventure using Open Telemetry, so then you start to have this, you have this inventory of services who's build traces and metrics, but then you have few solutions that start building service map to see the communications. And usually when you start to putting the first bricks in your observability, or say um, uh, observability, techniques or decisions internally in your organizations, you say, oh, I'm going to start by understanding who is talking to who. So getting that network map, and I think the service mesh is doing it pretty well. And I think with a solution like Humble, you get also that details. So I think from the nature of the technology that Cilium relies on, eBPF, it's very lightweight, and you get that the details that you're looking for without adding extra workload. Because if you take a solution like Istio without ambient mesh, you will have to have all those envoy proxy injected as a sidecar. So you just increase the resources that you're eating in the cluster. So I think from a resource perspective, eBPF makes completely sense. But again, it gives you the network and the understanding on who is talking to who, and if I've applied some filters, network filters, or policies in my cluster, I can see if they're doing what they're expected. I think that's a great valuable assets in terms of observability to understand what's going on in your cluster. But again, it's not, you don't finish there. You need to add more things on top of that. So I think it's one of the brick from your observability stack that you need. But if you want to have a full understanding of what's really going to happen, what's really happening in your cluster, you need obviously more stuff deployed in your cluster.
Well, so forgive me. I had assumed that Cilium was a sidecar solution. It is not.
It is not.
How
The
so? How are they embedding?
So the way they work, so they have various components, but most of them is deployed as a daemon set. So they deploy
Oh, I see.
programs on each individual nodes, and
And they're
those
surfacing it through that. Yeah, that makes
yeah,
sense.
and those pods are basically deployed as eBPF programs, and this is how they understand what are the communication that is happening from a network perspective on the node, so they can understand, oh, that pod is discussing to that pod and that namespace, and then you get that information.
So I really like the design, but it's particular to Kubernetes. If anyone's not familiar, daemon set is a pod that's installed on every node. That's really the definition. And so I'm trying to, in my mind, I'm trying to think of, like my discussion earlier about zero trust. We're talking about our phones. We're talking about, so eBPF appears to be the front runner for zero trust observability. I'd argue, but then what does that look like when we're talking about scales and watches and phones and dog tags and you know.
So it's a great question. The problem, so for example, on ARM devices, I have no idea if the kernel versions support eBPF. I guess there's a lot of improvements. We should check it about it.
Okay.
Um, I know that there is a project from a Windows perspective. I don't know. I've not followed that closely, but I remember that Microsoft Windows wanted to also have a support of eBPF, which is by nature a Linux
I heard that.
uh,
Yeah.
process. And I think from the moment we got the support of Windows, the support of ARM device, so then, which means you can inject your kernel programs into Unix systems. It means that if I'm running on an iPhone or an Android, I would be able to inject my eBPF program, and I will be able to get some information. So I think that could be very interesting. Again, we need to double check if ARM devices are supported, because I think that will be
Critical. Yeah.
yeah.
My new Surface. It's actually in my car right now, but my new Surface laptop is an ARM machine now too. That's the Microsoft chip. They have their own chip now, which is kind of interesting. But I just felt, if you're familiar with think it's a German word, Gestalt. It means like, when the private eye like figures out who the murderer is, and they have there's this like kind of moment where you kind of realize. So I think you're right. I think we have to wait for a little bit more support from a couple more architectures, and then it'll be a different story, right? But Henry, I'd love for you to discuss with you, how do you tie together 1,000 different nodes, for example, or 1,000 different devices. And what I'm saying is, like, you described it as a program. You have this eBPF data, and then you ship it somewhere. For example, your employer, and they reconstruct it into actionable intelligence, right? Why is Tom's laptop talking to China? Or why is Tom's laptop talking to someone else that he shouldn't be talking to? Whatever, right? And so how does that work? So what do those programs look like? What's that data look like?
I think the collection part is quite straightforward,
Mm-hmm.
and this is where you need this small program in the user space that will enrich the data and add the right metadata. Because at the end, like you mentioned, if I'm collecting information about my phone, for example, I need to add the right context to that. Because when the data will be sent to an observability backend solution like Dynatrace, for example, then the intention is to index everything and connect everything together. So then, because we have the context, then we have the options to apply any rules or alerting or baselining or AI on top of that to figure out, is it normal, not normal? Because if you just send data without the right context, then it's just data, and it's very hard to utilize it properly. I think that the biggest work is similar to the actual work happening in the Open Telemetry. So there's a 17 convention happening, and now with the logging, they're merging the one from Elastic, which was pretty mature on the logging, with Open Telemetry. So then the 17 convention has been structured, and I think if everyone's is agree on that standard on, okay, so every HTTP request should be the metadata we should add is this. For I don't know, for SSL handshaking we add this. Then we have a unified or a structured way of sending data. So then we know what type of data I'm dealing with when I'm receiving it in my storage solution.
Yeah, I think it's very, very impressive. I think you zeroed in on it right away. It's the context. It's all about the context. It will be always about the context. With zero trust, for example, the best, um, on the back end of zero trust is this ongoing analytics, supposedly, right? So they notice that suddenly your connection went from Boston to Texas, right? And so it means there's something going wrong with the connection. But that's really the best example I've heard of, about zero trust. It's the geographic data, which is kind of easy to figure out. The geographic IP address stuff is all kind of figured out at this point. I think where I'm curious is, where are the other analytic opportunities? And it sounds like with eBPF, it would require a sizable infrastructure. It sounds like it would be a big like data processing. You have all this data coming in constantly for all these different devices, and then correlating it and finding those contexts. And it sounds like it's a hard problem to me. Do you have a perspective?
I think the eBPF is one of the long list of technologies that allow us to collect. So because as of now, you made a story of the zero trust, and I think I really agree with lots of people are saying that on the social media or on internet, that security is basically part of observability. Because if you want to do a security decision, you need to understand what's going on. So the both security and observability is really is working very close by together. So I think that's a way of improving the security and the zero trust story. And I think from a storage perspective, the problem is that we really want to have a clear understanding of what's going on in our environment, so we collect more and more data. And there are a few organizations that use their own storage solution for observability, and then they realize that storing that data, that massive data that we're just increasing, becomes very expensive at the end. Because yes, you need to have huge storage. You need to figure out how I sample that data. uh, and those type of questions and those problems, they are basically being managed since decades by observability vendors like Dynatrace or other from the market. And I think it's a big challenge. I mean, now we are just we already started this journey to the cloud where data has been exploded from the observability standpoint. And now if we move further with your story with the zero trust security, then imagine every device that we have in our hands are pushing data to an observability solution. So then we're going to just explode more and more information that we're going to ingest, process. So that will be just insane for sure.
I think you're helping me kind of understand the problem domain, because I'm kind of curious if maybe if you were to constrain, the analytics, I guess the backend analytics, to just like a reasonable amount of like rules, right? So like, you know, Tom never uses RDP, right? For example, so if there's an RDP connection, you have to kind of be curious about it. I wonder if you could just like constrain it to like the geographic, and then I guess like a subset. Like Tom only uses SSH, HTTPS, and and I don't know. So let's just say I only use those two protocols, and so anything other than that, then probably some malicious activity. I wonder if you can really constrain it down to 10 to 20 to 50 rules, and not be trying to process the world, right? I wonder, from what you just said, I'm kind of suspicious that ingesting all this data and trying to make decisions on it just isn't efficient or possible, right?
I think it really depends. I think it's the data that we are collecting, because the observed data, the rules that you apply and the sample decision that you want to apply really depends of the nature of the data. And so here, if you take like data that will be required to make a security decisions, to filter a drop or make an alerting that we have some suspicious activities in our system, I think we don't need to necessarily have a long data retention. We just need the right time, so then we can apply the rules that we need. But then there is always a story about, I am collecting data from my logs, from my application, my users, from the response times, because I need to answer some requests from the marketing, from the business. I need to answer some people on the networking side. So everyone is interested to get the data, because at the end, when we have an incident, when we have a problem, we want to have the data in our hands. So then we can say, oh, it's simple. Is the card service is been killed due to that this type of stack, or in fact, what happened is that there was a library that was also vulnerable, and that we had an attack in parallel. So if we have all that context, then at the moment we have the incident, then we can make the right decisions. And if the data, similar to the security rules, if we have the right data in hands in case of an incident, then we can apply the right remediations to, I don't know, restart the service, or redeploy a new package that is less vulnerable. So we have plenty of use cases for that. But I think still, depending on what you want to really achieve with the data, you clearly need more longer data retention, maybe bigger sample rate, because you need more data. So it really depends on the use case for sure. But in the security aspect that you mentioned, maybe yes, the data retention could be shorter for sure.
I have to admit, you really have my wheels turning. You have my brain really going. So have you seen this? The CISA is the Cybersecurity and Infrastructure Services Agency. It's an American agency, and I know you can see you turning your head. And so the pillars of it are identity, device, network, environment, application, workload, and data, right? And then I just want to call your attention, the very first platform those pillars sit on is observability, right? They're calling it visibility, right? And I clued in on it right away when you said it. You said a lot of people that you agree with say that security is all about observability. You remember exactly what you said? What was your quote?
Yeah, it's clearly, if you want to make the decision of filtering something, you need to understand what's going on, and to be able to understand a situation, you need to have the context and the data, and that is clearly observability. So I think security will become more and more efficient if we are combining more and more observability data that we're collecting from our environments, or we extend the collections of data for sure.
Yeah, well put. And then you notice right away, observability and visibility and analytics sits on top of automation and orchestration. And by the way, I just realized neither of us had kind of introduced ourselves. But my background is automation. I've been automating forever, and a passion of mine. And then as we can come back to that, and then finally governance. And governance really is policies, right? So it's having the right policies. And so in the Cloudflare example I was talking about, there is a internet-wide firewall called the Magic Firewall, and you can define firewalling rules to allow or disallow connectivity or connections to various destinations or sources, or you can orchestrate all that through this kind of internet-wide firewall system, the Magic Firewall. It's very cool, but you know, forgive me for asking this, and this is I think this is a pretty tough question, but what do you see the role of automation in observability, like in this big eBPF cluster example that you gave, the 1,000 node cluster? I mean, how could you do it without automation, right? I'd argue, but like, is it as simple as that, or is there more to it than that?
I think it depends of the automation, but I think even automation systems needs to drop their own informations or their events, because events is cheaper to store than metrics. So if an automation process starts, you can throw their events, add the right metadata, and then it becomes events. And then if we have problems with the information coming from the automation, from the CI/CD systems, or from the deployment process, then we have even more information to say, oh, this is happening because we just released the version 1 point whatever, and the deployment. If you look at the tests that happened after the first deployment, we had this error, and nobody has looked at it, and that explains a lot of things. So with this information and the automation, I think it's really rich. My second aspect is that if you just think about our brain, and if you think of about let's say a Tesla. So if I drive a Tesla, the Tesla has tons of sensors. He can understand what's going on in front of the car, the side of the car. You get information from the GPS information. You have so many information, and then based on all that information that he's receiving, then the car drives and make decisions. And it's the same thing. If you want to apply the right automation, and if we want to apply this, I hate the terms AI because I think it's more machine learning. So if we want to have an automation that makes sense, that is smart enough to do crazy stuff, then yes, having observability side of that is like the eyes, the ears, the nose of our human brain. So we collect sensors, and then with that data, we make decisions. I think observability also can extend for sure the efficiency of automations. If we think about testing, we can even be more efficient on how we test, or help organization to test what is really required. So I think it opens a lot of doors, and to be more efficient and more productive in organizations.
I love that. That was really helpful. I do want to kind of directionalize the conversation a little bit with hyperautomation. Have you heard this term? It's a new Gartner coined expression.
Never heard about it.
Yeah. So we briefly discuss it with you. So it's kind of a new approach to automation. It's hyper automation, which is kind of a weird word. I don't expect it to be smelled with a hyphen, but anyways, what it is, and then at the bottom of the screen, I put up a direct link to this Gartner website. And so what it is, man, is you brought it up, is eventing, right? Eventing is kind of buried here in the middle, but eventing is a big part of hyperautomation. I've observed that at GitHub with GitHub Actions. GitHub Actions is this big eventing system. It supports like 30 or 40 different events, from a pull request to a commit to an issue, comment, and so on, right? Or, there's all these events, and just that incredible power. And the way I describe it to people, and I've written a blog about it for that upcoming conference, is that it's kind of like the Unix design philosophy. So the original Unix design philosophy was like small little programs that you could chain together with pipes, right? And so you have this event, you kick off this GitHub action, and then the GitHub action calls another process farther down the chain, and then you're able to string together. And then another kind of aspect of of hyperautomation is like low code, no code, right? And it's stringing together these different, and RPA, if you're familiar with RPA, which is robotic
Yeah.
process automation, but stringing together all these different things into cohesive workflows, very, very, very powerful workflows. And I don't think you have a chance to do zero trust at scale without something like hyperautomation, because you're touching so many different apps and processes and SaaS products, right? Like a lot of these SaaS products have an API, but you know, you might need to orchestrate them with like RPA, right? Like a web, like a GUI based RPA. Like it just might be the need, right? And so I think I mentioned zero trust is the biggest market I've ever encountered, right? And then hyper automation is like the second biggest market I've ever encountered. And so the combination of the two I find perpetually interesting, right? And so where I was going with that is like, what is like the low code, no code situation look like in this sphere that like is there anything out there? Have you noticed anything? It's kind of a difficult question, but what I'm getting at is like how simple is it to orchestrate and or code observability stuff? That's really what I'm trying to get at.
I think if you look at how the observability market is moving toward, it's going to changing. For instance, if you take just the example of Dynatrace, the new platform that we released 2 weeks ago, we of course do observability. We ingest data, but what we are providing to the market is the ability to index and store and query high volumes in very short time. For example, 1 terabytes in a few milliseconds. And once you have this cross signals storage solution, so events, logs, tracing, metrics, whatever, all glued together in one storage, then you can say, okay, so now I'm going to create a workflow. So now in Dynatrace, we have a workflow engine, and we have an app engine. And the idea is that we say, okay, so every time I receive that type of events, that so you filter, and then you define your workflow. So you don't have to necessarily code the workflow. We have like a workflow UI where you can just drag and drop boxes. So you say, oh, I just received that type of problem. So what should I do? And then you can say, okay, before doing anything, I want to do that, run a specific query to confirm that I am in that situation. And based on that query, so if I have this, then I will do this and this and this. So you can do very precise and fine-grained automation, and then not only call you can also call external solutions. So say I'm going to send an HTTP request to trigger a workflow somewhere else, or a remediation in Ansible, for example. So you'll have the options, but at the end, this workflow of making decisions on what should I do based on this type of situations, then you can drive it. You can design it without necessarily having any coding skills. So it's a very low code approach. And I think uh, the personas or the people touching observability, there's definitely two type of persons. There is the technical architect, engineer, building the custom metric, building the custom events on the code perspective. So now I control the type of data I'm going to send over. But then you have the persona that will be more closer to the reactions, or to the SRE, I would say, that will say, based on the data I'm receiving, I need to do something. And sometimes SRE, I mean, even if you have a coding background, sometimes you're very happy to just define your workflow instead of spending hours of designing. I mean, if you look also all the solution, Argo workflow is very efficient. So even if I don't have, for example, a solution like Dynatrace, I can basically build my workflow using Argo workflow, and that is quite convenient as well. So there's a lot of options today that allow us to automate and make decisions, like you said, like the hyper automation that you just described.
Well, that's a great explanation. So you did mention that there is a new Dynatrace product. Is it like version 5 or something of the core Dynatrace product, or is it a new product?
No, it's basically the upgrade. So the product that people are using as of now today, most of the user has been so the UI, it's called Dynatrace. We call it the second generation, and this one is the new generation, new platform. We've been working on it since almost 3 years.
Oh
So
wow!
it's and
Congratulations. It's out the
and then
door.
we had to keep it secret, and then
Sure.
we announced it during our user conference in February, and then since February or even earlier, we started to roll out customers, and we decided that okay, so now in June or May we have enough maturity to open it for new customers and prospects. So then if you start a trial in Dynatrace, you have now access to the new platform.
And what you were describing about kind of that low code and the difference in the personas and everything, I really kind of connected with. I think I have a personal like memory of like just like using Splunk, but having this very like almost like regular like PCR to E type regular expressions to try and find the right data. So, I mean, it was very challenging, but I'm glad to hear that you guys have tackled that. I think it's going to be very, very popular and very, very powerful. That's wonderful.
And I think the what we wanted, because I think every observability solution is pretty much on we're structured the same way, where we have the data, or in the past we there were no standard way of collecting the data, so we were investing more on the agent side. We build an agent that will collect and bring all the right information back to our solution, and then we index it and we store it, and then we build UI on top of that. That was basically mainly designed for a specific use case. Oh, I'm a Kubernetes engineer, platform engineer, or I'm more on the application side. So the screens will be basically focused on who is in charge of what are the persona, who is interested in what. And now I think with the new generation is that now of course, we still have our agents, but with the open telemetry movement, maybe people may want not to use any agent anymore. So the value is how we store the data now and what we do with the data. So of course, we're going to provide out of the box applications and screens, so people who doesn't want to invest and customize their own Dynatrace, they can use what we provide to them. But then now we have an app engine framework. So now if you have JavaScript coding skills, then you can code your screens. You can customize. You can. So we have a visualization framework. So you can run queries in our system, and then you can design whatever you want. So saying, oh, this app is fantastic, but there is too much information. I want to change it. I want to basically design the screen that will fit for the marketing team, design the screens that will fit for the
Oh, that's
business
cool.
analytics teams, and so on.
Oh, that's brilliant. I missed the connection. You mentioned it, but I missed it. That with the new product and open telemetry, can you speak to that?
I mean, as of now, we still have our agents out there. We've been building it, so we will still maintaining it. And I think in bare metal environments, our agents are very useful, because with one agent sitting in the host, we collect everything that is required. But now with the open telemetry movement, there is a lot of great auto instrumentation libraries that collect traces out of the box, metrics from the systems. If I use the Java auto instrumentation library, I will have information about the JVM, the garbage collector, a lot of various informations. And then you can also enable few, let's say, I want to collect information about AWS. If I'm running my workload on AWS or GCP, I can do that. So now OpenTelemetry is is stable on traces and metrics. We should have, I hope very soon, logs. It's even more I think very exciting to have a structured and standardized format for logs. So then when we receive logs, which because it's been structured and standardized, it's going to be so much easier to process and deal with the data. So that's super exciting. So I think now I would say you don't get all the as much as details as you want, but if you combine OpenTelemetry one end, StatsD on your hosts, you can drive how you want to collect information. This of course is going to be very challenging and expensive journey. But if you decide to say, I don't want to have any vendor agents in my environment, because then I'm going to be locked in. Now with all those technologies, you can have the option to say, oh, why don't I use the standard formats? So then no proprietary vendor solutions are being deployed in my code or close to my code. So then if I need to transition or change, I can do it very much more faster than I used to do it a few years back.
When you were kind of discussing this new approach, I really get the sense that it really is a platform, and it reminded me very quickly of like the iPhone. The iPhone was like a platform for applications and so forth. And so I really see, what you guys have produced is like the platform for observability. It sounds wonderful. Congratulations. Yeah.
Thanks.
Yeah. I think in the interest of, Lated's getting for you and so forth, I think, we've been going for 45 minutes, but before I let you go, I just wanted to let you introduce yourself. I didn't do that at the beginning, so I'll let you do it right now, and then I can move that to when I edit it, I can move it to the beginning. And then if you can also answer a very, very critical question, and it's, do you have any hidden talents? And so if you wouldn't mind introducing yourself and letting us know if you have any particular hidden talents.
Hidden talents? All right. So my name is Henrik Rexed. I'm a cloud native advocate. So I'm working mainly in the OSPO team at Dynatrace. So my expertise is Kubernetes, SREs, and everything. But when I joined Dynatrace 2 years ago, I really wanted to help our community to getting started on observability. So that's why I started this YouTube channel called Is It Observable? My intention is there is so many frameworks, so many way of collecting informations out of our cluster or our environment. So I thought, yeah, let's build content for our community, so then they can get started, they can understand that solution. And when you are working, it's very hard to step back and say, oh, I'm going to try this or I'm going to try that. So I'm trying to help by testing it for the community, so then they can look at my YouTube channel. Otherwise, prior to that, I was a performance engineer more than 15 years and plus. So optimizing and performance and networking, and that was my my way of investigating murder stories of performance in the IT environments. But yeah, that was mainly my what I used to do in the past.
In terms of great background for Dynatrace. That's a wonderful background, performance engineering. Yeah.
Yeah, I think I think from performance engineers are usually very curious, so you usually go deep on problems. So I think
definitely.
It's a great way of transitioning for sure.
What was the deepest you ever got? Was it like a month-long journey? How long do you think it was?
Sorry?
So I'm asking, how deep, for a particular problem, do you remember, like you focused on it for exclusively 2 weeks or 3 weeks or 10 weeks or 20 weeks or,
It really depends on the project that I had to deliver. Usually, performance engineer, when you were doing some gigs, it was very short. So you were trying to do your best and find the solution as fast as possible. So you were trying. Observability was not there, but we were trying to get as much details as required to then analyze and say, oh, now I understand. And I think that I thought it was really great. So sometimes I remember when I started, I really enjoyed tuning Java systems. So I could spend 2 weeks just tuning
like, it's more than just like the heap size, right? Like there's a lot to it. Yeah. Mm-hmm. Yeah. And then did you have any hidden talents? Anything in particular?
Oh, hidden talents. So I used to do some podcasting, so I still like it, and I'm starting to enjoy doing videos. So on my personal time, I also do some. I don't publish that publicly because I don't see the value of that, but it's more from just for private. So I do videos, and also I like to cook. I like to cook, prepare good food, and also sports. So I do downhill mountain bike. This is I love it. Windsurfing, skateboarding, and also depending if the situation out there, I can do some bodyboard or some longboarding.
Cool.
So enjoying being outside and skiing and all things that just fun.
Yeah, that sounds really nice, man. I love France. It's one of my favorite countries. It must be a nice place to live. But I'm gonna take us off broadcast, and I'll just say goodbye when we're off broadcast. But thank you. It was a real tremendous pleasure to meet you, and like I said, you're a new friend, and if you ever need anything, but I'll say goodbye as soon as we get off the broadcast.
All right, thanks.